Okay, chapter 12.1, Finding Square Roots. First of all, a quick definition. A square root of a number is a number that when multiplied by itself equals the given number. So if you want two numbers that multiply together to get 9, so think of two numbers that multiply to get 9. The square root is how you write it of 9 is equal to 3, because 3 times 3 is 9. So the square root of a number is a number that when multiplied by itself, this number multiplied by itself equals the given number. So the square root of 9 is 3 because 3 times 3 is 9. The square root of 25 is 5 because 5 times 5 is 25. And if you use a calculator, you can find other square roots quickly. Let's see if our calculator will do square roots. No, we need a better one. I'll find one real quick. Hold on, pause. Okay, so this is a better calculator. If we look over here and we want to do, say we do square root of 7. We say equals 2.64575. So 2.64575131106 times itself would equal 7. There's a lot of square roots that are a little hard, but there's some perfect squares, and those are numbers that work really well. Like the square root of 16 is just going to be 4, because 4 times 4 is equal to 16. The square root of, where do I clear it? There we go. Square root of 36 is going to be 6, because 6 times 6 is 36. The square root of 100 is going to be 10. You can see all this happening right here. Now these are all perfect squares because they have integer square roots, and we're going to talk about that in a second. But if you just pick a random number like 23, I guess I should put the square root in first. The square root of 23 is 4.795. You have to multiply. See, 4 times 4 is 16. 5 times 5 is 25. So it's somewhere in between, and it happens to be, if the square root of 23 is 4.79. And I can show you that real quick over here. So if we just think that, let's say square root of 23, we know that 4 squared is equal to 16, and 5 squared is equal to 25. And so it's somewhere between 4 and 5, because 23 is bigger than 16 and smaller than 25. And you could see from that it's 4.795, so it's closer to 5, and that makes sense. Okay, so a perfect square is a number with integers as its square root, and an integer is a whole number, kind of. You could also include negative numbers, but square roots are typically going to be positive. Well, actually, yeah, well, we're going to get into plus and minuses later, but we're not going to do that now, so we'll just not even talk about that. So, perfect square is a number with integers as its square roots. So those are the ones I've given you, like the square root of 4 is 2. It's a perfect square. The square root of 9 is 3. You can probably start guessing for me. Square root of 16 is 4. And the next one, you guessed it, square root of 25 is 5, and so on. You could just keep going. Okay, let's, I guess we should point out that this symbol is called a radical sign. And some people will just talk about doing radicals. And you'll say, I do square roots, what's a radical? And you're really talking about the same thing. The number under the radical sign, like this 25, is the radicand. And might or might not be really important for you to know. That's the radicand, and that's the radical. Okay, so we're just going to start working on these. Example 1 find the two square roots of 49. Not 42, my favorite number, 49. So 49, the square root of 49 is 7. And because 7 times 7 is 49. But, and this is what the book wants you to understand, negative 7 times negative 7 is also 49. So the square root of 49 is equal to 7 or negative 7. You could say 7 squared is 49, or you could say negative 7 with a parenthesis squared is also positive 49. So there's two answers, 7 or, and actually we probably shouldn't even say or, we probably should say and, because there are two answers. That's an interesting thing. When math, we start getting more than one answer. So find the square root of 25. That's example number 2. Because 5 squared is 25, the square root of 25 is 5. Okay, does that make sense? So the square root of 25 is 5. We're not necessarily having to find 5 and negative 5 right now. Looks like we're going to mostly talk about the positive square roots. All right. Let's go ahead and move on. He gave us a little trick here. That's why I erased it. We got the square root of 9 over 16. Now we have this negative sign out here, which is important, but we really could just look at the square root of 9 over 16. And we can recognize 9 and 16 both as squares on their own. We could do a couple of things. One thing we could do is we could just split it apart so that we have the square root of 9 over the square root of 16. And we still have this negative sign out front, but we've taken this radical sign and split it into two radicals in a fraction form. And these are actually equal. Okay, so that would just turn into negative 3 over 5. Not over 5. 3 over 4. Because the square root of 9 is 3 and the square root of 16 is 4. Okay, and we could also recognize that 3 times 3 is 9 and 4 times 4 is 16. So we could just remember, this is the second way, we could say, well, 3/4 squared is equal to 9/16. So negative square root of 9/16 would be equal to negative square root of 3/4 all squared. And since the square root and the squared cancel each other out, you get negative 3/4. This is a longer way, and you probably would jump right over this step. The book wants you to understand it, though. So we're going to use it. Let's look at the third example in section 2. And they give us plus or minus the square root of 2.25. And this will require a calculator. So let's go back, 2.25. And we're going to just go ahead and clear it all out. Square root of 2.25 is equal to 1.5. Now we might be able to do this in our head, but we don't know that 1.5 times 1.5 is 2.25. Some of us might. We might recognize that 15 times 15 is 225. But we didn't, so we came and used a calculator. And a lot of times when there's decimals and you're finding square roots, it's okay. So the square root of 225 is equal to positive 1.5 and negative 1.5. So there's two answers there, and the book really wants us to recognize that 1.5 to the second power is equal to 2.25. So when we have a plus or minus the square root of 2.25, that comes out. But I'm thinking that calculators are really what we need when we have these decimals. So on your own, what's the square root of 36? Find two square roots of the numbers. So when it asks you for 2, if you have 36, you've got to take the square root and you've got to come up with 6 and -6, and so on. It's really important that when you see these fractionals, plus or minus the square root of 4 over 25, you have to remember that that's kind of like plus or minus the square root of 4 over the square root of 25. And the square root of 4 is 2, and the square root of 25 is 5. So you've got plus and minus. So there's two answers. You can see that there. That's going to pretty much do it for us. Hopefully all of that was good times for you. Oh wait, one more little thing. Example 3. 5 times the square root of 36 plus 7, and they want us to evaluate this. Well, we're going to come straight down. We're going to keep this 5. We're going to think, what's the square root of 36? Well, the square root of 36 is 6. And then we're going to bring this down too, the 7 down. So the square root of 36 becomes 6. And we just use our PEMDAS or our order of operations. I wrote a 3 here. Can you forgive me for that? This is supposed to be a 5. Hopefully that didn't confuse you. If it did, back up the video and look at it again and just imagine I wrote a 5 instead of a 3. 5 times 6 is 30. Plus 7, that's coming down one more time. And 30 plus 7 is 37. So this is how that looks as it flows by. Okay, one more. 1/4 plus the square root of a fraction being 18 over 2. Now this one, they're tricking you. Before I showed you that you could take the square root of 18 over the square root of 2, but that doesn't really help you because you can't do that quickly or this quickly in your head. But we could simplify 18 halves. So we're going to come down and write 1/4 plus the square root of 9, because 18 halves is 9. So sometimes we just have to go ahead and simplify that fraction to get something easier, because we can see now that this is 1/4 plus, not 9, 3, because the square root of 9 is 3, which is going to equal 3 and 1/4, because 1/4 plus 3 is 3 and 1/4. Ta-da! Okay, that's it.